Previously, we talked about the operations for polynomials, specifically adding and subtracting. Eventually, we will move on to multiplication, but before that, we need to look at these called properties of powers. And we're talking about powers in terms of exponents, okay? Powers means exponents. So when it comes to multiplication, we need to know how to work with these properties of powers. So we're going to learn about 4 of them. The first one is called product of powers. Powers meaning exponents and product meaning the answer to a multiplication problem. So we'll start off with a simple example here. Let's say they gave us 5 to the x to the 5 times x to the third. All right, so let's identify some pieces of this before we get to it. Now, the letter x, that's known as the base. The 5 and the 3 up at the top, those are the powers or the exponents. All right, so the base is the big thing at the bottom. The exponents are the numbers up at the top. All right, so what this means is, on the first piece, x to the 5, that means that there are 5 x's. I could also write it as x times x times x times x times x. Okay, that's x to the 5. The other one is x to the 3. So that means that there's 3 of them. So x times x times x. And those 2 pieces are still being connected by another multiplication. So what happens if we put these all together? We could just count it all out. I've got 5 here and I've got 3 here, so that's going to come out to x to the 8th power. Now, is there a way we could have done that a lot faster? So let's take a look back at the top. So maybe instead of writing those out and counting them, what do we just do with these 2 exponents up here when we multiply? We're going to add them together. So let's make the rule for that. I'm going to write it off on the side. If you are multiplying two terms with the same base, so we look at this case, both bases are x, so if they have the same base and we're multiplying them, so they have to have the same base, all you're going to do is you add the exponents. Add them together. So in this case, the 5 and the 3 made an 8. So if we're multiplying 2 things with the same base, we're going to add the exponents together. So let's use that rule for a couple more examples here. So let's say we had m to the 10 times m to the 6. Well, guess what? They have the same base. They are being multiplied, so we'll write that base, m. And if we're multiplying 2 things with the same base, we add the exponents. So 10 and 6 make a 16. So that could follow for any letter. So y to the 14 times y. So we've got 2 things with the same base, but the y, the second one, doesn't have an exponent. If it doesn't have an exponent, it's an invisible 1 right there. So now we know what to do. They have the same base, so we'll write the base, and now we add the exponents. 14 and 1 make 15. And we can do the same thing even if the base is a number. Let's say we had 3 to the 5 times 3 to the 4. They have the same base. That base is 3. We're being multiplied, so we add the exponents, 3 to the 9. And that's actually something we can take onto the calculator and find out, 3 to the 9th power. This even applies if there's multiple terms. So x to the third, x times x to the 6 times x squared. They all have the same base. That base is x. So we're going to add up all the exponents. A 3, a 6, a 2, and then this invisible 1. So adding all that up, you get a 12. So no matter, as long as they have the same base, we can combine those by adding the exponents. So let's get a little bit trickier. Let's see what we're actually here for. let's say we have 4 m to the 6 y squared parentheses 2 m to the third y to the 7 x squared. All right, now this doesn't look like anything we've done so far. We've got a parentheses connected to another parentheses, and when they're touching like that, that we know is going to be multiplication. So let's match up pieces here. Let's go piece by piece. So let's look at it. In the first one, we've got a 4. That's the number in front. In front of this one is a 2. If I ignore everything else, I have a 4 and a 2 connected with multiplication. Then 4 times 2 is going to be 8. All right, once you use it, get rid of it. So that actually didn't change any of our rules. 4 times 2 is just 2 numbers being multiplied. Let's move on. I have m to the 6 times, is there another m in the other one? Yes. So if we think about it, pull it off to the side, we've got m to the 6 times m to the 3. They have the same base, so we're going to write that m. And if they have the same base and they're being multiplied, we add the exponents. 6 and 3 make 9. So we're just combining like terms, but using today's power rule, or product rule, product of powers. So let's see, what else? I've got y squared and y to the 7th. They're being multiplied. So we have y to the 9th. Now this poor x squared has nothing to go with it, so we just pull it down and connect it to it. And there we have the answer, multiplying those two parentheses together. So we're using the properties from earlier, just now in multiple steps. We can increase the difficulty of this to now 3 parentheses. So let's see what this looks like. 3a b squared, c to the 4, b to the 6, c to the 7, 4ac squared. 3 sets of parentheses, but they're all again being multiplied together. So we can use the same thing. Let's knock out the front numbers this time, the coefficients. 3 times 1 times 4 gives me 12. Let's pick the letters. I've got A, no A's in the middle, and A here. So now we're matching up letters. We're matching up bases. A to the 1 times A to the 1 is A to the 2 because we need to add those together. Next letter is B. I've got B squared, B to the 6, and then no more B's, so that's B to the 8. And last thing there is going to be the C. C to the 4, C to the 7, C squared. 4, 7, and 2 makes a C to the 13. We've used everything that we had, nothing left, and we check, nothing else can combine together, so there's our answer after multiplying all of that together. All right, let's take a look at another rule. The next one is distributing exponents. All right. So for example, if we have 2x to the 4th power, we don't like that the parentheses are there. We have a 4 outside of the parentheses and a 2x inside. Kind of like if we had a number in front, what would you do with that 4? You'd multiply it in. So let's do the same thing here, but we've got to apply that 4 to everything inside. The 4 is an exponent. I've got 2 pieces inside, the 2 and the x. Right now, the 2 has an exponent of 1 because we don't see it. The x has an exponent of 1 because we don't see it. So what we're going to do is multiply this 4 to every exponent inside. So now I have 2, and 1 times 4 is 4, and then x to the 1 times 4 is also 4. And for the sake of our lessons right now, you've distributed it, parentheses are gone. That's an okay answer for right now. If you really wanted to, you can get on your calculator and do 2 to the 4th power and find out what that number is. 2 times 2 times 2 times 2 should come out to a 16. But for right now, we're just concentrating on distributing that number in. So let's look at another one. 4 x to the 3rd y squared with a 6 outside. So again, we want to identify how many pieces this 6 needs to go to inside. I for sure see a 2, a 3, but even the number in front, the 4, has to have a 1 on it. So this 6 is going to get multiplied to all of those. Think about distributing. We're going to do multiplying. So not adding this time, but multiplying. So we've got 4, 1 times 6 is 6. X, 3 times 6 is 18. And then finally, y to the 12. And again, we could take 4 to the 6th power, put it on the calculator, and find out what that number is, but we're working on the rules right now. Let's see one more of these. Four squared, a to the 3rd, b to the 4, z, and then a 7 outside. So I know this 7 needs to go to every power or every exponent inside of this. I see a 2, a 3, a 4, and on the z is an invisible 1. So let's apply this everywhere in here. So we got 4 to the 14, a to the 21, b to the 28, and then z to the 7. All right, so we're just applying that rule to these problems. Okay, so this one's pretty easy. All right, third rule of the day is called the zero power property. Zero power property. So just listening to the title, zero power, so zero exponent property, zero exponent. And here's the rule. Anything to the zero power, anything to the zero power is 1. So let's see. For example, if you took x to the zero power, doesn't matter what the base is. Once that exponent is 0, this answer is 1. Even if the base was a number, if it was 3 to the 0 power, anything to the 0 power is 1. It really doesn't matter. Even if we took my name here and put it to the 0 power, okay, we've got parentheses this time. I know anything to the 0 power is 1. Or we could use our distributive. Okay, distribute this to everything. 1, 1, 1. So it's c to the 0, a to the 0, o to the 0. That's 1 times 1 times 1, because anything to the 0 power is 1. And guess what? The answer is still going to be 1. Anything to the 0 power is 1. So what about this? X, y, z to the 0 power. Anything to the 0 power is 1. So is my answer 1 here? Unfortunately, this one is not. The difference between this one and the last one is the parentheses. Right here, this 0 is being only applied to the z. On the y, it has a 1. Okay, the 0 is not connected to the y, just to the z. And on the x, still just a 1. So the z to the 1, or sorry, z to the 0, that's just going to be a 1. Everything else is still there. So in the end, it was only the z that disappeared and became a 1. Everything else was just x to the y. And there's my answer. So just the piece that has the exponent 0 is going to disappear, not the whole thing, unless there's parentheses, and then that's a different story. One last rule for today. This one is quotient of powers property. So the first one we learned was product of powers. This one's going to be quotient of powers. Product was multiplying. Quotient is dividing. So this will be for our division problems. All right, so for example, we have x to the fifth over x squared. All right, so we think about it. When we were doing product, when we were doing multiplying, we added the exponents. When we're doing dividing, we're going to do subtracting exponents. So if we look at this, we've got 5 on top, 2 on bottom. So your answer is going to be x to the third. We subtract the top and the bottom. 5 minus 2 is 3. If they have the same base, we just subtract the exponents. We can do the same thing here. 7 to the 10th over 7 to the 2. If the base is the same, we can write that base. And 10 minus 2, 8. So when we got quotient, we just subtract. Now what gets a little bit funky is when we run into something like this. A to the 6 over a to the 9. We still have to follow the same rules. It has the same base of a, but we subtract top to bottom. 6 minus 9 actually comes out to a negative 3. The problem is we don't want negative exponents. Okay, so unfortunately we don't want to write our answer with negatives. We only want to write answers with positive exponents. Okay. Now, there's a quick rule to take care of this. Anytime you have a negative exponent, we can bring that or flip this entire fraction, because right now it could be over 1. We flip it and bring it to the bottom, and the 3 can become positive. But with that blank space, we need to put the 1. Now our 3 is positive, so this is actually an acceptable answer here. But sometimes we forget about this flipping rule, and so let's learn something else that may help us out. All right. So what I started to learn is maybe instead of subtracting, let's compare what's bigger on top and bottom. So let's start with this again. 4 squared over 4 to the 12. From now on, how about anytime we see a division problem, let's go ahead and write that division bar again. And let's compare like terms. So I've got a 4 on top and a 4 on bottom. Cool. So there's going to be a 4 in my answer. And now look at the exponents. Where is the exponent bigger? I've got a 2 on top and a 12 on bottom. Exponent bigger on bottom. So that's where I'm going to leave the 4. How much bigger is it on the bottom than on the top? It is bigger by 10. So it's kind of like we're doing subtraction, but now it's already on the bottom where we want it to be, and everything's going to stay positive. The only problem is I've got a blank space on top, and anytime I have a blank space, we fill it in with a 1. All right, so we got 1 over 4 to the 10th power. So let's see if we can do this one a little bit faster. How about m to the 6 over m squared? From now on, let's do it as this. Let's write that division line again and compare it. 6 m's on top, 2 m's on bottom. There are more m's on top, so I'm going to leave m on top. How much bigger is it on top? It is bigger by 4. And anytime there's a blank space, we can put a 1. Now really, if we put a 1 down here, does that really mean anything? No. So the answer is just going to be m to the 4. But if you have to put an m on the top, it has to show up in your answer. M's on the bottoms don't really need to be there. So let's get a little bit more advanced with these problems. Let's say we have w to the 9 over h to the 4 next to it, x to the third over h to the 10, w to the third, x to the 0. It's a division problem. It's a quotient problem. So anytime I see this, I'm going to draw this division bar again. And now let's compare by matching up letters. It really doesn't matter how you start. I'm going to start with this W. I've got W here. I've got W there. So let's match up. There's W's on top and W's on bottom, but there are more W's on top. So I'm going to leave W on top. It is bigger by 6. All right. I'll go ahead and go to H's now. 4 H's on top, 10 on bottom. The H's are bigger on bottom, so H stays on the bottom. It is bigger by 6 again. And now let's do the X's. Is it bigger on top or on bottom? Bigger on top, so X is going to stay on top. 3 on top, 0 on bottom, so that's bigger by 3. We have no blank spaces. We have something on the top, we have something on the bottom. There's our answer. And that's more how we're going to see things. Now you also notice another thing I could have done is instead of x to the 0, x to the 0 is also a 1. And then if there's no x to go with that, the x to the 3 stays how it was. A to the 10, b to the 6, y squared over y to the 8, x to the 3rd, a to the 4, and b to the 6. Anytime we see a division, let's write that division again. So let's match up. A's. I do have A's on top and bottom. It is bigger on top, so A stays on top and it's bigger by 6. 10 on top, 4 on bottom. Let's move to the next letter. I see B's. Now notice this. I have 6 on top and 6 on bottom. B to the 6 over B to the 6. If it's the same amount, they're actually going to cancel each other, and now there's no more B's left. Move to the next letter. Y. 2 on top, 8 on bottom. That's a Y on bottom. Bigger on bottom. Bigger by 6. And finally, the X's. Are there any other X's to go with that one? Nope. So we leave it where it is, x to the 3rd. And finally, one last problem. Let's say we had 24 n to the 6 m squared z12 over 6 z7 m5. It's a division problem. So let's draw that division bar again and let's compare top and bottom. This time we have a weird 24 and 6 in front. Let's leave that for later. We know what to do with the letters. So let's match up. N. 6 on top, no n's on bottom, so let's leave 6 or n6 on top. So that's done. Z's. I have 12 on top, 7 on bottom. Top is bigger by 5. And then M's. 2 on top, 5 on bottom, 3 left on the bottom. And now once I've crossed out all of that, imagine covering all the letters up, and then it says 24 over 6. That looks like division, right? So let's do it, but let's apply the same rule. Which one's bigger? 24 or 6? 24. So when we divide these numbers, the answer will be where the bigger number was. So 24 divided by 6, we always work it up and down. So 24 divided by 6 is a 4, and since the bigger number was on top, it'll stay on top. So just real quickly, let's say we had something where it was blah, 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 10, 2, and then a bunch of other letters here. 10 and 2 do divide to a 5, but the bigger number is on the bottom, so 5 would go on the bottom, and then the rest of the letters. Okay, so just quick review. Long video, but these are all the properties of powers. We had multiplying. I'm going to scroll back through all this real quick. We've had multiplying, or product of powers, where you add the exponents. We had the distributing exponents, where you multiply into the parentheses. We had the zero property power, where anything to the 0 power is 1. And finally, A little bit of the longest rule down here was the quotient rule, where we compare top and bottom, and the big one always survives. Okay? If it's bigger on top, we leave it on top, and then we say how much bigger it is. Same thing with on the bottom.